Now that we've been working with radical expressions, we need to learn how to solve radical equations. So a radical equation is going to be an equation that has a variable underneath a radical or a square root symbol. When we solve radical equations, I have the steps written out here. The first thing we're going to do is isolate the radical expression. If you're struggling with what the word isolate means, it basically just means we're going to get the radical or the square root part of all by itself on one side of the equal sign. Very similar to what we did first semester when we solved linear equations. We would always try to get the variable by itself on one side of the equal sign. So we'll do that by first getting rid of anything that's being added or adding or subtracted to the radical, and then we'll get rid of anything that's being multiplied or divided to the radical. Once we do that, we're going to have to get rid of our radical symbol or our square root symbol. Well, remember we've talked before that to get rid of a square, we use a square root. So to get rid of a square root, we're going to square. If we square one side of the equation, remember an equation's like a balance, so we also have to square the other side of the equation. So those are going to be our first two steps. From there, we're going to follow any steps we learned previously from solving linear equations to get the variable all by itself. Now, there's going to be some situations where there's only a variable under a radical, so we don't have to worry about step 3. But there's going to be other situations where there's an expression involving a radical, or excuse me, an expression involving a variable under the radical. So then we have to make sure to get a variable on only one side, add or subtract to get the variable alone, and then multiply or divide to get the variable alone. I have 4 examples where we can look at how this works. So looking at the first example, notice that I have an x underneath a radical, so this is a radical equation. The first thing I'm going to do is get the radical expression all by itself. So if I draw some lines down my equal sign here, notice I do have 2 sides to my equation, so getting that radical by itself, I'm going to have to get rid of the plus 4, so I'm going to go ahead and subtract 4 from both sides. Doing that leaves me with a radical x on one side. I drop my equal sign down. 2 subtract 4 is -2. I've now completed step 1. Step 2 says I need to now square both sides. So I'm going to go ahead and square the left side and square the right side. Doing that makes my radical and my square cancel each other out, so I'm left with just x. My equal sign again drops down. -2 squared is -2 times -2, which is +4. So notice that in this particular case, once I got rid of the radical, I didn't have to do anything to solve for x. X was already by itself, so I'm done here after step 2. I can always check to see if I've done my work correctly by plugging my answer back in as well. Moving on to example 2. I'm going to go ahead and follow the same steps. So first thing I'm going to do is I'm going to try to get that radical by itself. My radical being right here, square root of 4x. So I'm going to have to get rid of the subtract 6, and I'm going to have to divide by 2. To get rid of the subtract 6, I'm going to go ahead and add 6. And then doing that gives me 2 square root of 4x equals 12. And then I'm going to go ahead and divide by 2. And I get the square root of 4x equals 6. Now I have my radical by itself. So notice in the first example, I only had to do one thing to get the radical by itself. Here I had to do 2 separate things. I had to add 6 and I had to divide by 2. Now that I've gotten the radical by itself, I'm going to go ahead and take step 2, which tells me to square both sides. So I'll square the left and I'll square the right. Doing so, my radicals cancel on the left. And I'm kind of out of room, so I'm going to scroll up here, and I'm going to have 4x equals 36. That was step 2. Step 3 says now to follow my steps for solving a linear equation to get the variable by itself. Well, I don't have anything, variable's only on one side, I don't have anything to add or subtract, so I'm just going to divide to get rid of the 4. The 4's cancel, and I get x equals 9. And again, I can always plug that back in to check my answer. Moving on to examples 3 and example 4. I can no longer see my steps but you should be able to see them on your paper. So now from here, again, I want to get the radical by itself, so I'm going to go ahead and get rid of that plus 7 by subtracting 7. And I get square root of x equals 5. Step 2 tells me to go ahead and square both sides, so I square the left and I square the right. That then allows for my radical or square root to cancel out, and I'm left with x equals 5 squared is 25. Plugging that, actually then from there I'm done because now I have x all by itself. So notice again, this is very similar to example 1 in the aspect that I don't have to go back and resolve for my variable. Moving on to the final example. First thing I'm going to do is try to get the radical by itself. Well, notice that now I have 2 radicals as opposed to 1, so I just need to make sure one of them is by itself. And notice that in this particular instance, they're both by themselves. So I'm going to go ahead and jump right away to step 2, which tells me to square both sides. Well, in this instant, notice that both radicals get canceled out, so I'm left with x plus 10 on the left and 6 minus x on the right. So now moving ahead to step 3, I want to go ahead and isolate or get my variable on only one side. So I could either subtract this x from both sides or add this x to both sides. I'm going to go ahead and add, even though it really doesn't matter which. I just like to avoid negatives if at all possible. That then gives me 2x plus 10 equals 6. Getting rid of add or subtract before multiply or divide, I'll subtract 10. Giving me 2x equals negative 4. Move that up a little bit. And then I'm going to go ahead and divide by 2 on both sides. And I get x equals negative 2. And I thought I had 4 examples. It looks like I have 5. So if you haven't tried one yet, this would be a good one to pause and try. Okay, and notice that example 5 is very similar to example 4. The radicals are both already by themselves on each side, so I'm going to go ahead and square, leaving me with 3x plus 1 equals 7x minus 9 because both of my square roots cancel out. I do not want x's on both sides, so I have to move one of my x's. Say I subtract 3x to get rid of the left x, leaving me 1 equals 4x minus 9. I'm going to go ahead and add 9 to both sides to get rid of add or subtract. 10 equals 4x. Divide by 4. And x equals 10 over 4, which of course reduces to 5 over 2 for my final answer. And sorry, that 2 kind of landed right on the line, so it's a little bit hard to read. I probably just made it worse. So 5 over 2. And that's how we're going to solve a radical equation. So just a real quick recap. We first get the radical by itself. If there's radicals on both sides, just make sure that one of them is by itself. We do that by adding and subtracting or multiplying and dividing. We square both sides to make our radicals cancel out. And then we follow our steps for solving a linear equation. And then the fourth step that I really didn't go over in this video is you always should go back and plug your answer in to see if it works. That kind of will be the next topic we move into. We'll look at what does it mean and when they don't work. But it is always a good thing to go back and check to make sure that it really does give you an accurate solution.